Hello everybody and welcome back to episode 61 of the video series in which we program an entire video game from scratch in the C programming language. Over the last several episodes we've been working on the game code DLL, separating all of our quote-unquote platform independent code into a separate DLL which we could then dynamically load and reload from our main game executable. And I feel like we have proof of concepted that to a degree, and I, I want to basically do something a little bit different today. I'm not saying that we're not going to continue with the game code DLL. All I'm saying is that I would like to put it on the back burner for now and go back to some simple game development stuff just because I feel I don't want to get too far away from making progress on the game itself. So, without further ado, I think I'm just going to dive in here and start actually making progress on this game and making it look like what we want it to look like. So, let's see. Let's fire this up. Let's see where we're at. So we're walking around here. We run into a random monster encounter. The first thing that I want to do today is I want to fill this black box in with something, and it's going to be some scenery, and then there's going to be a monster in front of it to represent our random monster encounter. Um, yeah. So if we go to Overworld, I believe it's Overworld Draw. Oops, it's actually battle. Here it is right here. What I was looking for was this call to draw a window just to verify that we are in fact drawing a 96 by 96 pixel window. So I think I would like to draw a 96 by 96 pixel bitmap that represents the scenery that's supposed to go inside of that black box. So here we go, new sprite, 96 by 96. Okay, here it is. So the only scenery that we really have, well, we have two bits of scenery right now, right? We have the outside overworld, which is like a plains, grassy area, and then we have one sort of dungeon indoor area. So what am I going to do here? So again, I'm not exactly a good artist, so what I'm going to try to do here is basically draw a line there, and then I'm going to fill it with a green color. And then we need to have a blue sky back there. I feel like the ground, there should be a bit of a gradient to it. I wonder if you could do a dithering effect with this program, Asaprite. Considering the nature of this program, I bet there is a gradient or a gradient with dithering blur, jumble blur. Ah, here we go, dithering. That's what I was looking for. Dithering. I've got to figure out how to work this program. It doesn't seem to want to work, so I'll come back to that later. I just want my pencil now. Pencil tool. 1 pixel. I want to draw some little grass. Okay. Now let's draw a cloud back here. I feel like Bob Ross. Let's do an ellipse tool, maybe. Can we make it filled? I guess not, but that doesn't matter. Paint bucket. There we go. Now we have some clouds. Suppose there should be like a mountain or something back here. Or maybe some rolling hills. And by the way, this is an NES color palette, so I don't like. I know I've talked about this before. I don't know if I really want to stick strictly with an NES color palette, or if I want to sort of give myself license to use more colors when I need to, because the NES color palette is very restricted and pretty ugly. But at the same time, you don't want to use too many colors because that breaks the nostalgia factor. It breaks the immersion, and we are going for sort of a retro style game here. So anyway, and then maybe put some trees, little trees back here on the horizon or something, just something to break the horizon up. But for now, we're just going to go with this. So, oh, we have to turn it to a 32-bit per pixel thing, don't we? Which I probably can't do with this program. I cannot. So what we're going to have to do is, let me first find the right place to save this. Save it in assets. I guess it's time to make a new directory. We're going to call this, what are we going to call this? Battle scenes. Okay. And then we're going to save this as Grasslands 01. Okay. assets, battle scenes, Grasslands 01. Now what we need to do is we need to open this with paint.net. Okay, and now we just need to save as, file, save as, BMPX, save. Then what do? We need to rebuild. Is it build.bat, copy assets.bat? Okay, bitmaps. Assets. Battle scenes. Grasslands 01.bmpx. Log to the log file. Alright. Look good? Yes. And I'll go ahead and run that. Rebuild the log file, rebuild the assets file, assets.dat. Okay, I think we are ready now to go to the code, go to main.h. Need to declare this somewhere. Where are the rest of our game bitmaps? There's our data structure, game bitmap, tile map, game map, hero. Here we are. Game bitmap, game bitmap. Overworld. How to name this? Like so, I guess. Okay, now to main.c. Let me copy this. To main.c, go to asset loading thread. Okay. Copy this. Paste. Grasslands01.bmpx. That is what it's called, right? Remember, our assets.dat file does not have a directory structure, so it's pretty much just flat inside there. But here on our file system, we do have a directory structure. So, yeah, grasslands01.bmpx. And we're going to store it right there. Okay. Okay, now it is loaded. We go to Okay, so now I've gone back to battle.c, and now we need a way for the game to determine whenever we have hit a random monster encounter. How do we know? How do we know which battle scene to draw? So it's basically tied to what kind of tile are we standing on, right? So, because if we're standing out in the grass, then we need to draw the grasslands one battle scene. But if we're indoors inside a dungeon, we need to draw a different battle scene that looks like it's indoors, like it belongs inside a dungeon or a cave or whatever it is. So one thing is we probably don't need that draw window call at all, because instead of a window, we're going to draw a bitmap. But then again, the bitmap does need a border, doesn't it? So we'll maybe we'll draw a 97 by 97 pixel window that is horizontally centered, vertically centered, and also is bordered. Right? And then inside that window, we are going to draw something based on the tile, the kind of tile, the type of terrain that we're standing on. So we've done this before. We've done this kind of work before. Over in, where was it? It was draw debug info, right? Where we draw the numbers, the numeric value of each tile over around where the player is standing, just for debugging purposes, right? So let's go to, where is that? Is it in main.c? Draw debug info, or no, it's not here, is it? Oh, it is here. Okay, here it is. What is the value of the tile that the player is currently standing on? So what we do here is we do an integer to ASCII, which we don't really need. So essentially this number right here, we take our tile map and then we do an X and Y sort of coordinate system of our tile map. And then each one of, like, y divided by 16 is the y coordinate that our player is currently standing on, and x divided by our player's world position dot x divided by 16 will get us the value of the tile that we're currently standing on. And the reason for that is because we know that each tile is 16 pixels, 16 pixels square. Okay, so this right here is the value we need for the value of the tile that the player is currently standing on. So I'm going to copy that and take it back to battle. And I guess we're going to switch it. Whoops. Do over. Main.c. Copy, Control C. Back to battle. Paste with Control V. There we go. There we go. We're going to switch that value. And the case is going to be tile grass 01. And then of course the default is going to be we're going to crash. So we're going to assert 0 with a message of doesn't matter. Message is random monster encounter on an unknown tile. Random monster encountered on an unknown tile. Right? So the only ones we have today are, well, we have portal, we have grass, we have debug, we have brick. Brick 01. But of course, in the future, we're going to have other, other types of grass. Like, say for example, let me just start the game up here. Asset loading failed. All right, so we did something wrong here. And what is it that we did wrong? Check the log file for more details. I have a feeling that we might have. Well, let me just check the log. I'm on debug x64. This log was last updated right now. So let's go to the very bottom. It says asset loading failed, file not found. Grasslands was not found in the archive. Why was it not found in the archive? It's because why? That appears to be a current archive. Current working directory should be right here. Right. Game B64 debug. Copy assets.bat. Oops. Actually, I wanted to do copy assets.log. Oh, here we go. That could be our issue right there. The file. Oh, look, I missed that. It was a misspelling. And that is why we built all of this debug logging stuff in there right from the get-go. That's why it's so important to make sure all of your stuff is instrumented and logging is occurring so that you can debug things like this. Let's go back to our batch file, which is right there. Edit. Battle. There we go. Battle scenes. Right? Save. Run it. And I think that should be all we have to do. So let me just try to load this up again. Yep, looks like it was loaded correctly this time. So back to what I was originally trying to tell you. If you take this, for example, we've seen this 1,000 times by now. All of my grass tiles are the same. I want that to eventually be different. I want to make several different types of grass tiles and randomize this stuff. So just to give it more variety. You wouldn't have seen that in the original NES. You would have seen it where every grass tile was identical, but that's because back with the NES they had to deal with draconian hardware restrictions and memory restrictions that they didn't have the space in a 40 kilobyte cartridge to store a whole bunch of redundant types of tiles. They only had space to store one type of grass tile. Famous example of this would be like Super Mario 1 NES should give us the famous opening scene, which is you can see right here on the right side. If you look closely, you'll notice that see the green bushes right here that I'm pointing to with my mouse cursor. There's the green bushes right there. Those are actually the same. It's the same bitmap as the clouds. if you look up in the sky, it's the exact same bitmap. They're just colored differently. And there's a very good reason for that, and it wasn't just because the developers of this game were lazy. It was because they only had 40 kilobytes of memory to work with. They were trying to squeeze an entire game, including all of the code and all of the data, all of the music, noises, sounds, bitmaps, everything, into a 40 kilobyte cartridge. So they had to take every shortcut that they could possibly imagine to cram it all into that little NES cartridge. Um, we, on the other hand, using a modern gaming PC in 2021, are not subject to such restrictions. We have essentially all the memory that we could possibly imagine at our disposal. That being said, of course, we don't want to deliberately waste memory, but we certainly have more than 40 kilobytes of memory to work with here, and so we're going to make some nicer looking tiles to play with. So this is going to look like, one day this is going to look like this. 02, 03, right? So you'll have intentional fall through depending on whether your dude is standing on grass tile 1, grass tile 2, grass tile 3. You're going to get the same grasslands battle scene, so yeah, you get the idea. But as for now, here's what I'm going to do. I feel like I need another variable here, or a pointer, essentially. And it's going to be a pointer to a game bitmap. Okay. It's going to be a pointer. Okay, back to the switch statement. So if we're standing on tile grass 1, then battle scene is going to be, there we go. There we go. And we haven't done brick yet. But let's just make sure that this works first. Let's make sure the grasslands works first. All right, so now we're going to do blit 32 bit per pixel bitmap to buffer. Battle scene. The X and the Y is, I don't even know. Let's just run this and find out. I'm going to go to options. I'm going to shrink the window size all the way to the very smallest, and here's why. The reason, oh crap. Okay. So the reason it crashed here with window width must be a multiple of 4 is because I forgot, because it's been a few weeks since we implemented this function, right? So I forgot that I made it so that I can't draw a 97 pixel by 97 pixel window. It has to be 96. So again, that decision, it wasn't entirely arbitrary. The reason I did it is because we're using the CPU intrinsic STOS-D, which writes a D word at a time, which is 4 bytes. So every multiple that it has to be in multiples of 4, basically, in order not to overwrite any buffers. could I possibly work around that and make a draw window function that is capable of drawing windows in not in multiples of 4? Absolutely, and I probably will have to at some point because I I just feel like I'm going to want the flexibility of drawing windows in odd numbers at some point. So that's probably going to have to get rewritten, um, but not today. So let's change this back to 96 by 96 for now because edit, just stop. You know, I mentioned a couple episodes ago that stop and edit debugging information never seems to work well for me. So I basically just turn it off whenever I can. Okay, there's my window. I'm going to print screen. Going to go to paint.net, paste in my print screen, and this is all so that I can find the coordinate of this thing right here. Is what? Where is invert selection? There we go. 384 by 240. And finally, this coordinate is right there. Right there. Right there. 144 by 72. All that work just to avoid a little bit of math. 144 by 72. Is that correct? Who knows? Let's find out. All right, so we drew this. We're going to draw this at 144 by 72. Brightness adjustment, nothing. No brightness adjustment. Or actually, do we want... Yeah, we do want brightness adjustment on this. Thank you, autocorrect. Very helpful. Very, very helpful. Not autocorrect, autocomplete. You know what I mean. Okay, so question is that ready? Is that ready? Let's run it and find out. 144 by 72. Didn't work. Okay, question is, why didn't it work? Oh, wait, no. Why didn't it work? Am I going to need to debug this? Okay, let's say value. Okay, set a breakpoint there. We'll go back in and find out. Okay. Okay. Battle scene. Go over here. Oh. Okay. Well. Not sure if that's right or not. Let's keep going. Okay. We draw the window. We enter the switch, and we correctly determine that this is the tile grass 01. So now what should happen is we should assign one pointer to the other. And that's not what happened, is it? Or maybe, let's see. I'm sorry for not being able to type. I'm also sorry for that font size extension that we installed for Visual Studio. Can't seem to increase the font size in the watch window here, which is unfortunate. Take away that breakpoint. There we go. Okay, we did it. We need the border on that window, which means should we remake our tile? Battle scene could be 0. Just doesn't. Yeah. If I'm just trying to get rid of that static analysis warning. So, okay, good. It did decide to go away. Yeah. I don't really feel like this is necessary, but the static code analysis wanted to generate a warning if I didn't check that this was non-null, that battle scene was non-null. So anyway, back to the issue at hand. 144. Now, if I draw it 1 pixel over and down, I think I'm going to show, I'll expose the border on the top left of the window, but I will still draw over the border on the right and bottom side. Exactly. Which means one possible way of solving this would be to go back and make this 95 by 95. So grasslands.bmpx is there a layer? Is there a canvas size over here? I'm not that familiar with this tool, obviously. And needless to say, I don't think this needed to be said, but I'm going to get somebody to make better looking art at some point in the future. This is just what we call programmer art to stand in for the time being until we get some better looking art to go in there. There it is, canvas size. Let's try making this. If we make it 95, no, it'd have to be 94 by 94, wouldn't it? 94 by 94. To fit inside of a 96 by 96. Yeah. Okay. Save. And then go back to paint.net and we're going to open grasslands01.bmp, save as a BMPX 32-bit per pixel, overwrite. Yes, that's fine. Then we'll go back here, run copy assets.bat one more time. Okay, now I feel like it will fit and there'll be a little window border around it. We made the battle scene 2 pixels smaller. Okay. It appears like that works perfectly. Next thing I want to do is make a new one that is 94 by 94. And this one is going to be like gray. This is going to be for our dungeon, right? Gray. And then, let's see, maybe if we make some sort of doorway back here. We'll draw a line here. I should have drawn the lines first. There we go. That thing, let's just delete it. Go back. And here we go. Okay. Okay, do we have a darker gray? We don't. I hope it's somewhat apparent what I'm trying to do here, even though I know it's really ugly. I'm trying to make a brick wall that has sort of this 3D perspective to it. Again, you know, I will definitely make this prettier in the future. Yep, that looks really bad. And just for good measure, I'm going to draw a little spider. I can't. No, I can't do it. I can't draw a spider. That looks dumb. Never mind that. uh, maybe I'll turn it into something. Hold on. Let me get my color back. Gonna do like a crack in the wall. I could probably draw a crack. Just to give it a little flavor. Okay, awesome. Save this as I guess we're gonna call this dungeon 01.bitmap BMP. There you are. Okay. And then we need paint.net. Open it. Just so that we can save it again as a 32-bit thing called Dungeon 01. Save. Okay. Copy assets.bat. Copy. Just to try to keep things organized. Dungeon 01. Okay, cool. And then run it. Then back to our code. Main.h. Make a new game bitmap. G battle scene underscore Dungeon 01. Main.c. Asset loading all the way to the bottom of this. I wonder if there's a hotkey. I wonder if there's a hotkey in Visual Studio to automatically take you to the bottom of a function. I bet there is. I wouldn't be surprised. Dungeon 01. And load that into Dungeon 01. Loading. Dungeon 01 failed with whatever. Everything looks good. Alright, awesome. Now back to our battle. In the case that we are standing on a brick tile, we are going to change battle scene to G battle scene dungeon 01. Okay. Everyone like that? Any errors? No. Let's go make sure it works. We have our grasslands battle. It's about to take place. Let's warp into the dungeon and see what happens. Okay. It works well. Other than the fact that the colors are not right, and you know, we'll fix all the artwork later. The artwork stinks, but we'll make it better. Now I wonder if it's possible to encounter a random monster if I'm standing on a tile. Probably not. I would think. Let's go to overworld.c. Already did portal handler. Is the player standing on a portal or a door? If else, should we? Okay, so I just had to verify for my own sanity that it is not possible to randomly encounter a monster if we are standing on a portal, which is good. That's what I wanted to happen. Next little thing I would like to fix is I want to give our player a grace period for whenever they encounter random monsters. For example, right now it is configured so that every step you take, you have a 10% chance of running into a monster, which means that occasionally what will happen is you take a step, you run into a monster. Let's say you win the battle, and then you take another step. On that very next step, you might just encounter another monster. Let's say you beat that monster, you take another step, and there is a chance that you will run into another monster on that very next step. And I find that is very annoying to most players. So I think there should be a grace period where you can't run into a monster unless you've taken, let's say, at least 5 steps since the last time you encountered a monster, right? And the question is, do I want to make that grace period variable, or do I want it to basically be constant throughout the lifetime of our game? And I think right now I probably want it to be constant. So we'll say, well, first I've got to find out where all my pound defines are, somewhere in main.h. Pound define, here we go, debug, assert, here we go, game resolution, the number of steps the player must take before, the number of steps the player must take after the previous random monster encounter before another random monster encounter can take place. Pound define, what are we going to call it? Random monster grace period steps 3. There. So we'll say that you have to have taken at least 3 steps since your last random monster encounter. So now we're going to go to our player data structure, which is right down here somewhere. Hero. Okay, direction, movement. Has player moved since portal? We're going to do to steps since last random monster encounter as a long variable name. Let's keep our random monster stuff next to each other. Okay, steps since last random monster encounter. Guess that'll work. So now we'll go to overworld. If a random monster encounter occurs, we want to store that. We want to do gplayer dot steps since last random monster encounter equals gplayer dot steps taken, right? And then we essentially need to do if gplayer dot steps taken, since steps taken will always be greater than or equal to steps since last random monster encounter. So this should always be a positive value. It's always going to be 0 or greater, right? So if steps taken minus steps since last random monster encounter is greater than our constant value, which is, I've already forgotten because I can't hold that much in my head. Random monster grace period steps. Overworld. Oops. Overworld.c. Wrapping all that up into there. Okay, so the net effect here should be that we can never run into a random monster encounter right after each other. We have to take at least 3 steps before we can encounter another random monster. So let's see if that actually works, and then we'll be done. I mean, it's going to be hard to verify, but I should probably put total steps. Don't I put steps here? Frames, CPU, memory. That's weird. I should put I should put steps here. Sorry. All right. That was about 4 steps, wasn't it? Okay. Fighting random monsters. Now I'm in the dungeon. Fought a random monster. So it looks like it works. So it looks like I have no chance of running into a random monster within 3 steps of my last random monster. So that's a nice little bug to have fixed. And with that, I think we're going to call it a day. So what we're going to do next time, I think, is we're going to we need to just put the monster on top of the battle scene, right? And then we need to start drawing. So there needs to be a little monster right there in the middle. And then we'll start drawing some UI elements over here. We need a UI element, a window over here in the top left to show like your HP and your magic points and all that kind of stuff, your gold and vital statistics. Down here, bottom center, we'll have a little scrolling, battle log that says things like you hit the monster for 8 HP, and then the monster strikes you for 25 HP, and all this kind of stuff. So that is the kind of stuff we'll work on next time. That brings us to, wait for it, conversion from 64 to 32, because this is 64, that's a 32. So let's just, you know what? I'm just going to make it a 64. There. Anyway, that brings us to the end of this episode. If you liked what you saw today, you would like to see me continue the development of this video game, then please hit the like button. Please subscribe to the channel, tell your friends, etc. Also, don't forget that we have a companion GitHub repository. If you want to clone the repo on your own machine and follow along at home, we have that companion GitHub repo. I keep it updated in step with these episodes. And lastly, if you have any questions, comments, concerns, etc., please don't hesitate to leave those comments on the video in the comments section. I will address any interesting comments in an upcoming episode. And with that, that's all I have for today. So again, thank you very much for watching, and I'll see you